Unit 7, Graphing Quadratics Retest Review. Quick reminder, even though you're watching this video, you need to make sure you can do all these problems by yourself before retesting because your retest is extremely similar and it is also free response. Question number 1. What are the domain and range for the graph shown? Well, because we're going left and right forever, right? We're going left and right forever, our domain here is just all real numbers. The range, however, does not go up and down forever, right? We kind of start here at this point and then go up. So we have a starting point. So all the y's, okay, they start down there where y is -4 and then they go up. So all the y's are -4 or higher. In other words, all the y's are -4 or greater. So we say all the y's are greater than or equal to -4. All right, that's it for number 1. Number 2, what is the vertex of the following graph? We have we have f of x. First of all, you guys need to know f of x is just y. If it makes you feel better, just go through here and write y for these. You can totally do that. So we're going to graph this thing. I'm in y equals already my calculator. I'm going to put in 2 parentheses x minus 5, just exactly like I see on my paper. Then we got this, oh, or not. Okay, then we've got this little squared symbol on the end of the parentheses. Don't forget that. And then we got a +3. Take a look at my graph here. What is the vertex? Let's see. Well, hopefully we know the vertex is this point right here. If you don't know that, you're in trouble. You need to come talk to me. All right, this is my vertex. This looks like 1, 2, 3, 4, 5, over 5, up, 1, 2, 3. That vertex looks about 5, 3. Check your table just to be sure. And let's see here. That vertex was the lowest point on my graph. Is 5, 3 the lowest? Yeah, right? 3 is the lowest y value, right? Look at your graph. 3 is the lowest y value. So if you look at your table, that's your vertex for sure. All right, we got 5, 3. And on your test, that's all you got to be able to do is give me the point, the coordinate of the vertex. The next one is asking you for the axis of symmetry. Now in this case, the graph helps most of the time, but sometimes it doesn't. So what I want to remind everybody is that we actually have an equation for this. We have a formula for this rather. We have x equals -b over 2a. And to use it, you just need to remember that this number here is a, the number with x is b, and the number on the end is c. So we're plugging numbers in then. We got -b, and what was b? Okay, b was -3. Over 2, and then a. What was a? A is just 1. All right, plug them in and clean it up. So we've really got -3, which is +3. 2 times 1 is 2. So x equals 3 over 2. If you want to write a decimal for that, that's also fine. So x equals 1.5. Always a good idea to take a look at your graph just to confirm and make sure this is looking reasonable. We've got x squared minus 3x plus 9. And if I look at my graph, okay, I can see that my axis of symmetry would go right here, which, yeah, look, it's not exactly at 1, it's not exactly at 2, it's right in between, which makes sense because we got x equals 1.5. Okay, take a look at number 4. We are asked what are the x-intercepts of the graph. So again, let's get a graph. Get your calculator out, put in this new equation. I know it's a bunch of typing in your calculator, but that's fine. Right, the whole test was called graphing quadratics, so be prepared for lots of graphing. All right, I got my -x squared minus 5x plus 14. Let's take a look. Remember, I'm looking for my x-intercepts. Okay, I got one right here, and I got one right over here. So let's draw a little sketch on our paper. X-intercepts looks like this. And these are the points we're interested in. Oh, you know what? I drew my thing wrong. It was going the other way. Doesn't really matter that I can't see it all because I'm only interested in these points on the x-axis. So this one looks like it's about 2. And this one looks like it's -1, 2, 3, 4, 5, 6, 7. Always double check in your table. So I can graph. Let's see here, -7. Yep, -7, I'm at 0, and 2, I'm at 0. So I've got x equals -7 and x equals 2. Question number 5. In order to answer question number 5, you need to have a basic understanding. This is just function notation. We actually did this in the second unit of the whole year. we've got f of x equals, and then you get this equation, 3x squared plus 2x minus 1. But then on the end, it's asking for f of negative 4. So it's crucial that you understand that because x was in there, and now negative 4 is in there, that we should know that this number in here is an x value. So our final answer, f of negative 4 equals whatever, this is going to be a y value, right? They gave us the x value. We need to answer with the y value. I definitely think the easiest way to do this is to put this equation into y equals in your calculator. You can totally do it by hand just by plugging in the negative 4, but easier to make mistakes that way. So we got 3x squared plus 2x minus 1. And now I don't need my graph. Remember, I just need my table, right? Because this is an x and I need the y, so I can really just look in my table. So I'm going to go second, not y equals, second graph, and I'm looking for x is negative 4. Okay, right here. When x is negative 4, y is 39. That is it. That's my answer. So whatever number you're given in here, find it in the table for the function you're also given. Okay, so 39 is my answer. Okay, number 6, describe how the graph of the parent function y equals x squared changes if the function is changed to y equals 2x squared minus 4. So for this question, you guys were looking for things like it got skinnier, or it got wider, or it shifted up, or shifted down, shifted left, shifted right. Those are the things that we want when you answer this question. So go to y equals, and let's actually see it, right? Let's put y equals x squared into our calculator here first. So we got y equals x squared. And let's remember what this looks like. This is just a quadratic right through the origin. So now we're supposed to say what happens, how does it change when we end up with 2x squared minus 4? Let's see. Okay, well my new graph, my red graph, is narrower, right, skinnier, and also shifted down. And we should kind of know that. What you were taught in class is that if I have a number in front of x squared, this changes my shape. Right, in this case, made it narrower. And this minus 4, we're going to say shifted the vertex down 4. All right, and that's all you got to do for this is tell us what changed. Describe the transformation. Okay, on the back side of this thing, these 3 questions, we are using the graph, and it's actually super simple. Here's what's going on in the graph. Jane, the star shooter is the star shooter on our basketball team. The equation y equals negative 5x squared plus 20x plus 4 is graphed below, so you don't have to graph it yourself, which is nice. And it shows the path that the ball takes once it leaves her hands. So, for how long? So our answer is going to be in seconds, right? For how long is the ball at least 19 feet in the air? Okay, well, it's 19 feet right here and 19 feet right here. But it says how long is it at least 19 feet? So isn't it at least 19 feet for all this time? Yeah, and how much time is that? Well, looks like we're counting by ones, which is great, makes it easy. And we can see that from this point to this point, we did 2 seconds, right? 1 second, 2 seconds. A lot of kids want to tell me 3 because they see 1, 2, 3 lines. Nope, nope, nope. Okay, make sure you understand we're counting seconds. So 1 second, 2 seconds. 2 seconds. So for 2 seconds. Okay, question number 8. When is the ball at its highest point? Well, I think we can all agree that the highest point is right here. So its highest point is 24 feet. But that's not what this question asks. This question asks, when does that happen? All right, so it looks like that happens at 2 seconds. All right, at 2 seconds. And what is the maximum height the ball reaches? Yeah, we just circled that. That was 24 feet. So this question, you're figuring out how long it's a certain height. And these 2 questions, you're using the vertex. Last but not least, we got a table. What do we do? Pretty much all the time. Hopefully you know. We're doing stat edit, y'all. This test is on quadratic, so please make sure that you choose option 5, because if you choose any other option, you will be wrong. So I have already put these into my stat edit to save a little bit of time. Right? I have my x's in L1, my y's in L2. Just the same thing from your paper, right? So if I'm going to get an equation for this now, I got to go to Stats, click over to Calc, and I'm choosing option 5, linreg. Sorry, quadreg. Keep clicking Enter till you get there. And here we go. So we've got y equals, a is 3, so we got 3 with x squared. B is negative 2, so we got a minus 2 with x. And then finally we got this plus this positive 9. Do not put the r value. The r value is just there so you can make sure that it is a good equation for the table, right? An r value of 1 means it's a perfect quadratic relationship. All right, just a quick reminder. I know I said it already. I'm going to say it again. Make sure you can do all these problems by yourself to be prepared to take your retest. Good luck.